Okay, today we're going to look at the Pythagorean Theorem and how we can use that in everyday world problems. Let's look at an example here. A basic example is a right triangle like this, in which we know our hypotenuse is 15 and this leg is 12. We do not know this leg. So we're going to go a squared plus 12 squared equals 15. It does not matter which one you label A and which one you label B. So let's go ahead and simplify our squares that we can simplify. 12 squared is 144 and 15 squared is 225. Let's use our algebraic skills to figure out what A squared equals. A squared equals 81. We cannot have a square on a variable. So in order to cancel that, we do a radical, a square root. So A equals plus or minus 9. We always do plus or minus 9 because negative 9 times negative 9 also equals 81, just like positive 9 times positive 9 does. Let's look at another example. This is similar. This time we don't know the hypotenuse. We do know the sides, the legs though. One leg is 10 and one leg is 20. So we have 10 squared plus 20 squared equals c squared. 10 squared is 100. 20 squared is 400. And we keep simplifying as much as we can. Again, we have that variable on the we have that square on the variable, so we have to use a square root. If we simplify this, we come up with plus or minus 10 times the square root of 5. And that's as simplified as we can get. Depending on your problem, you may have to go ahead and put this into your calculator and come up with a decimal. But unless you're told to do that, you can leave it in radical form. Okay, we're going to use the Pythagorean theorem to measure distance. We can see that from here to here is 1, 2, 3 spaces. So that distance is 3. We can see that from here to here is 1, 2, 3, 4 spaces. So we can use the Pythagorean theorem to go 4 squared plus 3 squared equals c squared. And we can find the straightforward distance from here to here. 4 squared is 16. 3 squared is 9. It equals c squared. This is 25 equals c squared. Can't have the squared, so c equals 5. So this distance is 5. And that's how we can use the Pythagorean theorem to measure a distance when we have 2 points. Using this distance formula, let's look at the distance between a point that's at -2, 9 and a point that is at 6, -5. Okay, in this we have x1, y1, x2, y2. And we're going to put all of this under a square root sign. And we have the second x minus -2, which is the first x, that makes it be plus 2, squared, plus -5x, or -5 minus -9, which causes it to be plus 9, squared. We can simplify this to be 8 squared plus -5 plus 9 is 4 squared. This can be really tempting because we have these squares and we have a radical. But remember, this all has to stay under the radical. It's not like a multiplication problem where you can break it apart. We have the square root of 64 plus 16, which is the square root of 80. The prime factorization of 80 is, let's see, something like, okay, the prime factorization of 80 is 2 to the 4th power times 5. That means 2 2's can come out. So our distance is 4 times the square root of 5. And that is our final answer right here. Because we're talking about distance, we do not do the plus or minus sign because we know that distance cannot be a negative number. Now we're going to look at a midpoint. As we already know, a midpoint comes halfway between 2 points, and it causes congruent sections. It means it goes exactly in the middle so that everything on each side of the midpoint is equal. And the way you find the midpoint is you go your x1, so let's make this be x1, y1, and let's make this be x2, y2. And we're going to go, our x's are going to add, so we have 1 plus 19 over 2. And this is going to be our x number. And then we have our y's, which are 3 plus 15 over 2. This is going to be our y number. So 1 plus 19 is 20 over 2, and 3 plus 15 is 18 over 2. When we reduce that, that turns into 10, 9. And we can see here we have our 10, and the complete midpoint is 10, 9. And if we count, we can see that this is 1, 2, 3, sorry, we need to count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's where we are, and we're up 10. Now, if we find the midpoint between these two, this point right here is 18. Let's see. Let's see. It would be 19. 1, 2, 3. And we have 19, 15 up here. So if we go our x's, x1 plus x2 is 19 plus 19 divided by 2. And our y's are 15 plus 3 divided by 2. So we're going to have 19, 18 divided by 2 is 9. So we're going to have 19, 9 as our midpoint here. So we can actually continue this out. And if we look at our midpoint here, it's going to be right here. And notice if we find midpoints all the way around on a right triangle, we end up with a right rectangle.